Welcome back. This is question 10. Let's finalize with question 10. You are given area under curve. And you're told the figure 2 shows a sketch of the curve C with the equation y is equals to square root of x into 100 minus x squared everything divided by 40, where x is greater than or equals to 0. The point P is a stationary point on C. Use algebraic differentiation to find the exact x coordinate of P. To find the exact x coordinate of P. So let's start with the part A. We're given the function y equals to root x into 100 minus x squared everything divided by 40. So this one can also be written as 1 over 40 into expanding the equation for y. We'll have root x times 100. This one is the same as 100 x raised to power half minus x raised to x power 2 multiplied by x raised to power half. This one is the same as x raised to power 5 over 2. Now we can differentiate this function with respect to x, keeping the constant factor 1 over 4 outside for now, so that what we'll have is dy dx will be 1 over 40 bracket. We start by a half multiplied by 10, not 10 but 100 power half minus 1 is the same as negative a half, then minus this one will be 5 over 2 x power 3 over 2, close the bracket. Simplifying this, we'll find our dy dx to be equals to 1 over 40 into, simplifying this, the same as 50 x power negative a half minus 5 over 2 x power 3 over 2. And remember, you are given the point P is a stationary point on C, and we know that at stationary point the gradient function is equals to 0. So we can say that at stationary point P, dy dx is equivalent to 0. So therefore we can equate the gradient function to 0, which will be 1 over 40 into 50 x power negative a half minus 5 over 2 x power 3 over 2. This one should be equals to 0. What we can do here, we can multiply both sides by 40. So here what we can have is we can multiply both sides by 40, so that what we remain with is simply 50 x power negative a half minus 5 over 2 x power 3 over 2 to be equals to 0. Now we can multiply through by x power half to clear the negative power. So this means if at all we want to get rid of the negative power, since power half is common, what we can have is we can factorize. We'll have x power half into, of course this one will be 50 minus 5 over 2 x power 2 and everything equals to 0. So what we have done in this case, we can multiply both sides by power negative 1, power half So what we can do here, we can now multiply through by x raised to power half to clear the negative power, so that what we remain with is simply 50 minus 5 over 2 x squared equals to 0. So maybe if I can highlight in this case what I've done is just to multiply by x power a half. Of course, for the purpose of removing the negative power from x. So simplifying this further, this is what we are going to have. You can take negative 5 over 2 x squared the other side of the equal sign, so that we remain with the 50 equals to 5 over 2 x squared, cross multiplying by 2, we're going to have 100 equals to 5 x squared, divide through by 5 by 5. We can have x squared is equals to 50, not 50 but 20, because 100 equals to 20. Remember, 20 can be, for us to remain with the value of x will be equals to root 20, and this one is just the same as 2 root 5. So we can say that the exact x coordinate of P is 2 root 5. Now we can also look at part B, and in part B, going back to the question, part B, you've been told the region R1 shown in figure 2 is bounded by C, and the x-axis, the region R2 also shown shaded in figure 2 is bounded by C, the x-axis, and the line with the equation x equals to k, where k is a constant. Given that the area of R1 is equal to area of R2, use algebraic integration to find the exact value of k. So in part B, we are required to find the value of k. And something quite interesting here that we can note is that the curve crosses the x-axis where y is equals to 0, and also since x is greater than or equals to 0, it implies that let's look at this. So this means that if we equate everything to 0 in this case, so part B, we can say that at x-axis y is equals to 0. So therefore, what we are given as equation of the curve will have 0 equals to root of x into 100 minus x squared, everything over 40 is equivalent to 0. So here we can get rid of you can multiply both sides by 40 over root x and also by 40 over root x. So therefore we'll say that 100 minus x squared is equals to 0. So in this case we'll have 100 equals to x squared, and therefore x should be equals to 10. So it means this means that region R1 is from x equals to 0 to x equals to 10, and region R2, which is below the x-axis, is from x equals to 10 to x equals to k. And remember that the area of region R1 is equal to area of region R2. So this means that the net area from 0 to k must be 0, because the area above will cancel the area below. So here we can argue that since R1 is equals to R2, so this means that net area will be equals to 0, of course from 0 to k. So having this, we know that for us to get the net area, then it means we'll have the integral from 0 to k of 1 over 40 into 100 x raised to power half minus x raised to power 5 over 2 with respect to x, and this one should be equals to 0. So we can integrate this keeping 1 over 40 in the expression. So this means that we'll have 1 over 40 into integrating this. Of course, you increase the power by 1, then multiply by the new power. So this one will be the same as 100 x power 3 over 2, everything over 3 over 2, minus x raised to power 7 over 2, everything divided by 7 over 2 from 0 to k, and this one should be equals to 0. So simplifying this further, we'll have 1 over 40 into, this one is the same as 100x power 3 over 2 divided by 3 over 2. This is the same as 200 over 3x power 3 over 2 minus 2 over 7 x power 7 over 2, and of course this one is from 0 to k, and it should be equals to 0. So we can substitute the limits when x is equals to k, and also when x equals to 0. So if we substitute the limits, then this is what we are going to have. We'll have 1 over 40 into 200 over 3 k power 3 over 2 minus 2 over 7 k power 7 over 2, and this one should be equals to 0. So what we can do, we can multiply both sides by 40 just to remove that 1 over 40, so that what remains is simply 200 over 3 k power 3 over 2 minus 2 over 7 k power 7 over 2, and this one should be equals to 0. Now since k is greater than 0, we can divide by k raised to power 3 over 2. So this one you can divide by k raised to power 3 over 2, k raised to power 3 over 2, k raised to power 3 over 2. So that what we remain with is simply these two can cancel out. We'll have 200 over 3 minus 2 over 7 k squared, and this one should be equals to 0. So taking this the other side, we'll have 2 over 7 k squared equals to 200 over 3. And at this point what we can do, we can cross multiply. We can multiply this one by 7 over 2 by 7 over 2, so that k squared should be equals to 700 over 3, and therefore k equals to the square root of 700 over 3, and remember this one can be simplified as 10 root of 21 everything over 3. And this is your final solution for question 10.